All right, so with quadratic functions, again, note-wise, we're keeping up with the notes. This is notes number 7. We are about halfway through the 9 weeks. So we'll have a few more here on the back end because we did a lot of review stuff in the beginning. But with quadratic functions, the biggest thing on this one is that when we're talking about if it's quadratic, x squared is your highest power. And sometimes they'll give it to you where you have y equals x squared with an equation. But remember, that's the same thing as f of x equals x squared. So if we're graphing these, they can write it either way like this. It's still the same thing. So just, don't get lost in that notation part of it. Technically, we should be doing functions, but sometimes they'll sneak in an equation, but it's still the exact same thing. All right, when we graph these, again, big difference between quadratics and absolute values was that absolute value was the V-shaped graph where it came straight in and straight out. Quadratics are going to be more of a U-shaped graph. So it's more something like that. Now we're still going to assume that we're still going to use 0, 0 as like our starting point or a reference point for everything. Now here's where we're going to add in a detail with this one. This bottom point that we have here, we'll get the definition of it in a second. Bottom point or top point where we got this part, we're going to call that the vertex. We'll give you that actual technical definition here in just a second. And then the other thing is that if we have a vertex on this part, the parabola, we'll talk about the shape of what x squared is. The shape is a parabola. Not parabola, but parabola. If you want a song to get stuck in your head that you're going to hate me for the rest of the day, think of the Muppet song. Do, 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 do. Mana, mana, do, 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 do. Parabola. Do, 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 do. So, yeah, instead of mana, mana, it's parabola. It still fits, got that same rhythm to it. So, yeah, thank you. You're going to have that stuck in your head the rest of the day now. So, okay.
We should play the Muppets for
Wait, what's the parabola again?
Parabola, that's the shape. The red shape there. Okay. All right. Yeah, the Muppets threw him off a little bit there. So. Okay, so your basic shape is always a parabola. The top or the bottom of the graph is what they call the vertex. And if you take the vertex, and it'd be hard on this one to see it, but if you draw a line right through the middle of the vertex, it should split the graph into 2 equal halves, which the mathematical term for that is called a line of symmetry. Or in this case, they call it an axis of symmetry. Okay, so everything that we do for when we're graphing the parabolas, when we're doing quadratics, everything keys off of finding the vertex. If you can find the vertex, everything else is really pretty simple when it comes off of it, because that is the most important point that you have on any quadratic that you're going to graph. Okay, so for the vertex of it, here's technically, the definition of what it is and what it means for all this stuff. When we talk about the vertex, that is the bottom or again, if it's going this way, it could be that it's the top point. So it's the bottom or top point of the graph. Okay, and we'll say that it's also the point that splits the graph, or point where the graph. It's also the point that splits the graph. Let's go ahead and keep it there. Into 2 equal halves. Okay, which again we said was a line of symmetry. That's our next, definition that we've got to put on for this part. So vertex, that's the most important point. And again, here's our axis of symmetry, definition for that one. Okay, if we start talking about these, so you don't have to write axis of symmetry every time, and this is not a textbook thing. This is a Coach Ritchie thing. We're just going to call it AOS for short. I mean, we can keep writing axis of symmetry every time, but if we know what it is, let's just abbreviate it, make it short here. All right, so the axis of symmetry, it's a vertical line drawn through the vertex. All right, and again, when we do that, it's going to split. When you draw that axis of symmetry, it's going to split the graph in half. Okay, so the vertex is the point that's in the middle of the graph. The axis of symmetry is the line that actually cuts it into two equal halves. So then that's, and again, if it's symmetrical, everything on the right side should be the same as what's on the left side. So it's that line of symmetry that you talked about back in middle school with some stuff. But this time it's always going to be just a vertical line that we're going to have for this thing. All right, and then the good thing with this one is the axis of symmetry equation. Again, just say AOS for short. It's always going to be, now if you have a flashback to when we were graphing a couple weeks ago, if it's a vertical line, it's like this. You might remember that's only one direction, right? So you might remember if that's x equals or y equals. It's going to be x, right? So the axis of symmetry equation is always x equals, and it's always the x equals, and it's the x value of your vertex. So again, if you can find the vertex, that's going to spend everything that we need. That's going to run off that, because the vertex is going to have the equation for the line of symmetry. We're going to talk about the max and the midpoint and the values that go with it and the range and everything else. So if you can find the vertex, it's really, really, really easy. And again, we're looking at today where it's going to be easy to find this. Yes. Yes. So yeah. So if we were backing up here, the axis of symmetry would be x equals 0 because it's just taking that point right there. Yep. You got it. Went too far there. Yeah. So it's always this point here. And the value goes right there. That pen is about to die. There it goes. Now it's moving. Okay. Okay. All right. Now for this one, here's what you're supposed to do when you graph a quadratic. We're going to kind of give you a little shortcut, cheap version of it, depending on what the problem is. But to graph quadratics, functions, equations, whichever way they give to you. The one thing you always have to do is you have to figure out what the vertex is. You're going to plot that first. You're going to plot the vertex. Okay. And then the second thing is after you've got the vertex, what you're supposed to do. Again, this is what you're technically supposed to do. We'll give you the shortcut of it in a second. You plug in or you evaluate the x value beside the vertex. And you do that to find the next order pair, to find the next point on the graph. Now, and occasionally, with some of the Math Excels, when they're making you graph it, sometimes they make you do another point. So then you'd have to plug in the next value over, or you could go. If the good thing is that if you pick one point to the right side of the graph, the next point to the left side of the graph should be the same value. So it doesn't matter whether some people are like, which way do we go? If we're, if we were graphing this one, does it matter if we go to the right and pick this point, or if we go to the left and pick this point for X? If it's 1 or -1 here, it doesn't matter, because the good thing is with it being symmetrical, whether you move one place to the right or one place to the left, this value here will always be the same. If you move 2 places to the right, or you move 2 places to the left, that Y value will always be the same. So it doesn't matter which way you go, it's going to give you the same answer either way. Okay, but again, most of the time, if you just pick one point, it's going to, with Math Excel, as soon as you pick the vertex and one other point, it's going to draw the graph for you. So it kind of does it. And every now and again, they'll make you do 3 points. I don't know why. That's just a little something that happens every now, because we've done it before where they're like, why am I doing 3 points? I'm like, I don't know. It's making you do 3 in this case. For me, I'm good with, most of the time I'm good with 2. Now, if it's really a tall graph or something like that, I may tell you to graph 3 points just so that we've got a really good idea of what's happening with it. All right, now here's kind of a good thing with this one. There is a whole number shortcut. And with the whole number shortcut, if we're graphing these, we're plotting these. And we'll show you a problem. Let me just go ahead and kind of give you a preview of the problem here. You remember when we were doing, I think we're doing some of these. If we were doing something like this, and this is where we're coming to here in just a minute. If we're going to graph this, we're going to plot some numbers here. That's basically, we said you always kind of look for in front that there's a number here. It's going to tell you it's kind of like the slope in this case. Same thing with these problems here, that if there's a whole number in front of X, you can use that kind of like slope to get to the next point. Now, and it only works for 1 point. It does not work for the second or third or fourth or fifth point, because with parabolas, you're squaring it. And if you square 1, it's always just going to be 1. So it doesn't matter what you do. If you move 1 space over, if you square 1, it's always going to be 1. And if you square 2, now we're talking 4. So it's going to change it. This only works to get to the next point. Every point after that, you would actually have to just go back and plug in the values for it so you can see what it is that's going to do. But if you need the next point, that's a shortcut you can do if it's whole numbers. If it's a fraction, it doesn't work. We figured that out one time because we were doing this for a shortcut, and we were going through, and then we had one in fractions that we did, and we tried it, and we were like, that didn't work. So fractions don't work, but only for whole numbers it'll work. Okay, so there's how we plot it. There's how we graph it. Here's what we need to see, because there's 2 different forms, and today we're taking the vertex form. Oh, need to go back. Okay. Sometimes they call it graphing form. Sometimes they call it vertex form. Some books just call it something a little different. Sometimes they kind of go back and forth on those two. So if it talks about graphing or vertex form, just realize it's the same thing. Okay. Now here's where it's going to be basically the same thing we did with absolute value, but the difference is instead of it being V-shaped, it's going to be the parabola. It's going to be the U-shaped graph of this thing. But the basic setup of it tells you everything basically the same thing for what's here. The A value that you have here tells the direction of the graph. Okay, so the A value, you can think about it kind of like slope. And again, it's not exactly slope at all, but it gives you that general sense of just like if it's a positive slope line or negative slope line, you can see what it is based on that one. The A is kind of that same way. It tells you the direction of the graph, that if A is positive, so if your A value is greater than 0, the graph points up. And Ms. Chapman would not be happy that I said the graph points up. And the technical term is the graph opens upward. That's the mathematical term of it. Because you get mad at first students if they said it points up. But if we were graphing this thing, again, the arrows would point in the up directions, would be something like that. Okay, so the A value that you have that's in front of, and again, A will always be the number that's in front of the X. It always tells you the direction of the graph. If A is positive, if A value is greater than 0, it points upward or it opens upward. And if A is negative, well, then it's going down. All right, again, the technical math version of it is that it opens downward, which seems funny that it opens down, but that's what they call it for that part of it. And again, so basically now we're talking about a graph that looks something kind of like that. All right, I guess I should have left a little bit more space underneath. I should have left just a little bit more space because the second thing we were going to do here, we put underneath that. So let's just do this over here. So we've got A is greater than 0, right? We've got a graph that looks something like this. I wasn't thinking, it kind of jumps a little bit there. All right, so for A is greater than 0, we've got something like this. Everybody okay that the vertex would be right here? Okay, vertex in that case is at the bottom or top of the graph? At the bottom, right? So if it's at the bottom, vertex is at the bottom. That means that your vertex is a minimum point. And a lot of times they'll just put max or min just for short. So if your vertex is at the bottom, the vertex is a minimum point or minimum value. Mm-hmm. So if we flip that around, I had A greater than 0, which means the arrows are pointing down. Vertex is at the top. Oh, whoops, my bad. Thank you. There we go. A less than 0. Thank you. It's a Monday, so you know. A little upset that the Artemis didn't launch this morning, so that's on my bucket list to go do is go watch a rocket launch.
scared that somehow I die. Like somehow.
Oh, you're like even when you're there. Look, we actually went to the Kennedy Space Center last summer, and even when you're there, you're still like 20 miles away from the launch site or something like that. I mean, you're far enough away if it blows up that you're fine. So maybe not 20 miles. It may be a little stretch. It's more like maybe it's 2 miles. I think it's 2 miles away. Yeah, something like that. Yeah, that'd be true. Yeah. So I think it is two. It's still a good ways out there. I know that much. Yeah, it's just maybe 2-3 miles away. All right. So for this case, the vertex is at the top. So the vertex is the max point. Okay, now here's where we're going to tie in a couple other things with this one. Whenever you do either one of these two, doesn't matter which one it is, we're going to talk about domain and range again. If it's a function, domain is always going to be negative infinity to infinity. So that's one reason why they talk about this being a function and not an equation, because sometimes with equations, they don't have to necessarily go from infinity. But if we're talking about a true function, your domain should be negative infinity to infinity, because you can take any number you want to, you can plug it in, you can always get an answer. Okay, for the range. Right, thank you. The range, and again, this is our x value, so we can go side to side forever. If you're doing the range in this case, we can go up forever, but we're going to stop here, right? We're going to stop at this bottom point that's here. So what we're going to do when we talk about the range, basically the range in that case is going to be whatever this y value is that's here. And it's going up. So basically we're going to start at that y value, which if you remember when we did these, we talked about the k value back here, that this was the movements we're going to do for this thing. Basically that's the k value, and it's going up to infinity. Yep. So back up here, and I actually forgot that back up here. My bad. Back up here where we had this equation. When you've got this one, remember that we talked about the a value. Remember that your vertex, that's just your h and your k values. All right, and just like we did with absolute values, you always have to change the sign of the inside number. So if this is a negative number on the inside, you would change that to a positive number here. If this had been a positive number on the inside, we would change that to a negative number there. So whatever that number is on the inside for the h value, your horizontal value, if you want to think about it that way, that sign, you always have to change that sign. The k value, it always stays what it is. If it's positive, it's positive. It's negative, it's negative. Question? Mm-hmm. And the h should be your x. So this is the x value of your vertex, and that's the k value of your vertex. So I got caught up on the a values here, and I forgot about telling you what the actual vertex was. So that's the important thing, is that your vertex is at hk. Okay, so if you've got the vertex, you also know what your range is going to be, because it's always going to be your k value, and you're going to go from k to infinity if it's positive. Now, the other thing they do with this one sometimes is that for the range, they may also give it to you this way, that it's going to be y greater than or equal to, because it's pointed up. And that's where I tell people this is where it should be easy. This is pointed up, so it should be y greater than or equal to whatever this k value is that's right here. I think they will either give you a number to play. If it's interval notation, they give you this one and you just plug in the number. If it's y greater than or less than or equal to, they give you, I think they give you like multiple choice. They give you like y greater than or y less than or something. So it'll be obvious in Math Excel when you do that. Yes, should be either greater than or equal to or less than or equal to. There's no, because this one we're actually using that point. So we actually get to, everything we do on that case is going to be square brackets on that part of it. Now, again, you can't do it with infinity because it's infinity. You can't end it. But yeah, this other value that's here, it'll always be a square bracket.
So why is it always greater than or equal to? Like, why is it never less than?
Oh, it is because this. If we do the next one here, this one actually is less than. Because now, if you look at this part of it, where we've got the a is less than or equal to 0, your domain is still going to be negative infinity to infinity. All right, but in this case, if you look at your range, everything is pointed down. So now you're going to negative infinity. So in this case, your range would go from negative infinity. And then when you go up, you're going to get here, kind of like a rocket launch, right? You start here, you're going to launch up to the top. It's going to get to a certain point, and it's got to come back down. So now that k value is going to be at the top of the graph. So for that case, since the range is falling down, we're going to do y less than or equal to k. Okay. And probably the biggest thing I've seen people get a little bit confused sometimes. They're like, well, if it's the max, shouldn't it get bigger? Well, remember, the max, that's as high as it can be, so everything else is underneath it. So if everything else is underneath it, everything else has to be less than the max number because that's the highest grade you can get on the graph. You know, once you make 100 on the test, the only option is if you can't make 100 again, you got to come down, right? So if you've maxed out, the only place to go is down at that point. You know, the minimum is the opposite. It's at the bottom, so all the points are above it. So in that case, if we talk about the range, then everything has to be above this number because that's the lowest point on the graph. Once you've hit rock bottom, then you've got to go up from there, kind of thing. Okay. Now, one thing they may ask you to do here, and it's not every question, but some of these they do this. If they ask for a man value, because again, we're talking about that this is the maximum point or the minimum point here. If they talk about here, if they ask you for man value, that's just equal to that k value. So you just basically take the vertex and you keep reusing it over and over and over, and you just keep recycling it and you keep using it for every single little thing that happens here. Same thing on this side. If they ask you for a max value, that's still going to be your k value. Question. Go ahead, kids.
So basically, the max value is always the y number.
Mm-hmm. It's either max or min. It's always the y value of your vertex. Yeah, and it's depending on which way the graph goes. If it's going down, it's the max value, and if it's going up, then it's the bottom. So then it's the min value.
But it's
always the k value. I mean the y value, because the x value is going to be what we talked about back here. The x value is always going to be the vertex part of it. Where we talk about that? Oh, back here, the axis of symmetry. That the x value is always the axis of symmetry. Basically, everything here, when we talk about domain and range and max and min values, that's going to be your y value when it comes off of it. Okay. All right. I think that's x value. Yep. Axis of symmetry is always x value. The max or min is always the y value. All right, so let's give you some problems. We'll dig through this thing. We'll graph it. Now, when we graph these, we're just going to do a quick sketch because I didn't get graph paper because most of these, it's pretty easy because they're all going to be whole numbers, well, except for the last one that we'll get to. But everything else should be something we can just sketch it and be okay. I'm actually going to start on a new piece of paper so I won't cram this thing in here. All right, so we're going to do everything we could do here. We're going to do the vertex. We're going to find the vertex, the axis of symmetry. Let's state the domain and range. And most of the time they either say the max or min because again it could be either or, just depending on the number. So max or min value. and then we're going to sketch it. All right. So the good thing is when you're going through these in the homework, most questions are not going to ask you to do every single part of it every single time. Sometimes they'll just ask, okay, here's a graph, sketch it. Sometimes it's going to be, here's a graph, sketch it, and tell me what the axis of symmetry is. Sometimes they're going to say, all right, here's an equation, just tell me what the vertex is, tell me what the axis of symmetry is, give me the domain and range, and then tell me if it's a max or min value. So occasionally they'll ask you to do everything. Most times they're going to just kind of pick a little couple things here and there when we go through those. All right, so first function we're going to do, and we'll do all these the same way because we'll make sure we get all the different options and make sure we go through everything here. So there's our function. All right, and again, the most important thing is finding the vertex because once you've got it, everything else is going to spin off of it. So for the vertex, again, you take the number that's on the inside, change it, in this case, from negative to positive. The number on the outside stays the same. There you go. So there's a vertex. Because the number on the inside is the H value, the number on the outside is the K value. And for this one, what would the A value be there?
1.
You just understood 1, right? So if they don't put a number there, then you just got to know that, all right, in that case, the 1 value or the A value is just understood to be a 1. Okay, so we've got our vertex. And again, we're going to abbreviate for this one. The axis of symmetry is always x equals the x number that's here. And then we need to figure out if it's max or min. So again, we get that one based on the A value. The A value is positive. So the basic shape of the graph is going to look something like that based on what the A value is. And if we do that, the vertex is at the bottom, which means that's going to be a minimum. There you go. All right. And again, your min value is your Y value. So the axis of symmetry is always the X value. The max or min value is always the Y value. I think on the online homework, they give you a box that you either click max or min, and then you just put in 3.
Okay.
Yeah. Yeah, it's either one or the other. And that depends on the A value. If the A value is positive like this, the vertex is at the bottom, which means it's got to be a minimum. Because if you're at the bottom, that's the lowest point, which means you got to have a minimum. Again, either they will give you that, or they will. I think there maybe is a drop-down menu. You either click max or min, and then you just put in the number. Okay. Now, actually, while we're here, we're going to go ahead and do. We've got the axis of symmetry. We're going to go ahead and do the domain and range. Because domain is always negative infinity to infinity. That will not change for any quadratic, anytime, anywhere, any way. Doesn't matter. Doesn't matter. The domain is always negative infinity to infinity.
So I thought that A equals 1 would be the minimum value, but are you saying that 3 is the minimum value?
Yes. The A value just tells you the direction that's going to go. So that basically tells you whether the graph is going up or down. The actual minimum value is the value of the vertex at that point.
Okay.
So that's where we're going. Now, and here's where we kind of tie that one in. So for the range on this one, this is where we tie this in. It's always going to be this max or min value. And then you've got to figure, are we going up from that value or are we going down from that value? Well, we're going up, right? So we need everything that's greater than or equal to that number. So whatever number you use for the max or min value, that's the same thing you'll use for your range. Okay. And again, sometimes they do it this way. Sometimes they may do it that way. So just kind of be comfortable doing either one of those two because they'll kind of could be either one of those two. It could be this or it could be that. Either way. And if you think about it, if that's the minimum value, we said if we're doing like order pair, we're talking about domain and range, you always start with the lowest value first. If this is the minimum number, it has to go first if we're talking about interval notation. So we need 3 and then everything greater. So we need everything greater than or equal to 3. Okay, so we've got vertex, axis of symmetry, we've got domain and range, we've got the max or min value. And then to sketch it, we're just, again, we're not going to get like super detailed on it. We just want to make sure we've got it here. That's going to be at 2, 3, so it's up here. All right, so we'll make it look a little bit more like that. Because this one's going to be more up this way, so just make it so that we've got more room up top here. All right, and vertex was at 2, 3. So that would be about here. And the other good thing is with the A value, if we're getting ready to graph this one, we just said a minute ago that we know that once we get here, this thing has got to go up. So you know this is going this way. The only thing you need is you've got to have at least 1 point. Sometimes they make you do 2 extra points past the vertex, but I'm usually good with 1 point. Give me 1 more point past this, and here's where we get to cheat a little bit. And again, this is not in the book. This is just something that we'll do. The A value, as long as it's a whole number, you can think about that as being like up 1 over 1. That if you want to get to the next point on the graph, as long as the A value is a whole number, you can just go up 1 and over 1 to get the next point there. And it doesn't matter if you go left or right. You can go to the up 1 and right 1. You can go up 1 and left 1. Either way you go, those should give you the next points that's on your graph there.
So do you go up 1 and over 1 because of A equals 1?
Positive, because it's positive. If it's positive, you're always going up and over. If it's negative, you're going to go down and over.
And that's because it's 1, or like it could be -1 for A equals 1.
Right, yeah. So if it was 2, we'd go up 2 and over 1. Okay, now technically what we're supposed to do, since this is the vertex at 2, 3, technically you're supposed to plug in x equals 3 back into the equation, or the function in this case. You would take the 3, plug it back in, you would work it out, and you would get your answer that way. But again, as long as it's a whole number, that's our chance. Because some teachers don't tell you this, but I kind of like when those, if it speeds the process up, I like to tell you, as long as it's a whole number, you get to cheat just a little bit because you can just go up and over if it's positive. If it's negative, you go down and over, and it gets you the next points. Now, it only works with whole numbers. If it's fractions, you got to do this thing. You got to take the x equals 3, you got to plug it back in, you got to work it out. And here's why it works for the whole numbers. Because what happens if you do 3 minus 2 squared? That's 1 squared, right? Which is just 1. So if you pick the next point right beside it every single time, this number, when you square it, will always be just 1, which is basically like using that like the slope, because the slope is just going to give you the next point over. So it's kind of that cheat part that as long as we pick it so this number is always 1, if you square it, well, then that's going to make a little bit of a difference there. Okay, so that's my trick for doing those. You know, if you want to be technical and go back and plug it back in and figure out that this point is at 3, 4 here, and then you look at it and you go, oh, well, if that's at 3, 4 here, this one's also got to be at 4, but instead of adding 1, now I'm going to subtract 1, so this next point that's here would be at 1, 4. Which to me is a lot easier to just say, all right, I'm just going up 1 and over 1, I'm going up 1 and back 1. Get you the same thing. So this is technically what you're supposed to do. But again, for the whole number part, I like thinking about it as like a fraction, where it's like kind of like slope. But that's only, and again, it's not a straight line, it's a curved line. So it's not exactly slope, but it's, you know, kind of sort of like slope. All right, everybody good so far? Any thoughts, any questions, Emma? All right, so this is technically, all right, this is technically what we're supposed to do here. We pick 1 point that's beside the vertex. So like if we know this is at 2, 3, we got to pick the next x value to the right that's over here at 3. You take that 3, you plug it back in, and you work it out, and it tells you what the next point on the graph would be. Now, we're going to use a shortcut. As long as it's a whole number, we're going to treat it like slope. So in this case, a value is 1. If we treat it like slope, it's 1 over 1. So the shortcut is once we're here at 2, 3, we can just go up 1 and over 1 and get the next point there. Which to me is a lot quicker than doing this thing and plugging it back in. So if that's confusing you over here, don't worry about it. Just forget about that.
I had
Okay.
up until the graph of the moving. And
Yeah,
then
so-
plugging in.
So this is technically what we're supposed to do, but we're going to do the shortcut. Okay.
Why did we make x3 if like 2 in the coordinate 2, 3,
Mhm.
x is 2?
Oh, you pick the next x value. So if the x value here is at 2, for the vertex we're here, you got to go to the next spot over on the x-axis, so you can go to 3, or you can plug in 1. So you just pick the next x value either to the right or to the left. Can I get you there? I think in that case it kind of works out a little weird because at this point is 2, 3. So it's not always going to be this number is going to be the same as this one because I think this is one of those probabilities that's going to get there. So all right, so let's show you one that's a little bit different where it's not quite that way. All right, so let's go with y equals x plus 4 squared. All right, so let's get all the basic stuff out of the way here. A value is 1. H on the inside, again, we're going to change it from positive 4 to negative 4. There's nothing back here behind it, though, correct? So if there's nothing there, okay, it's a 0. So you always need an inside number, which is your H value. You always need an outside number, which is your K value. If one of those happens to be missing, then that means that particular value is worth nothing. So it's a 0. Okay, so there's a vertex. All right, again, with the A value, the main thing is with the A value, it tells you the basic shape of the graph, that we know it's going up. Again, which means the vertex is at the bottom, which means then this thing is going to be a minimum. And that's going to be a minimum at the X value, sorry, at the Y value of the vertex, which in this case is 0. Okay. Yep. And then the axis of symmetry is just the X value. So that's X equals negative 4. Remember how we talked about when we were doing the absolute values that we always went the opposite way? Same thing on this one. You always change the sign on what's on the inside. Only the inside, yes. The inside changes, the outside stays the same. Okay, so we've got the axis of symmetry. We've got the min value, in this case at 0. We've got the vertex. Domain and range. Again, domain is always negative infinity to infinity. And a lot of times they won't even ask you about the domain just because it's the same answer every single time. They might ask it once, but usually after that they'll quit asking. All right, for the range, again, if this is the lowest point on the graph, if we're talking about range, as far as like where we're going, if we're talking about interval notation, that's the lowest point, so it's first. And this thing's going up forever, so it's going to infinity. Okay, but again, sometimes they ask for it this way, sometimes they ask for inequality parts of it. To me, the inequality is actually a little bit easier because it's going up. Up is greater. And again, it's always this min value that's here, so it's y greater than or equal to 0. Okay, so we've got, make sure we got everything. We've got vertex, we've got axis of symmetry, we've got domain and range, we've got the max or min value. Okay, so now we're just sketching. Okay. Let's see, this graph needs to be everything to the left, so scoot this graph way over to the right side. Because the vertex is at -4, 0, which would be right there. Okay, and again, with the A value, you know that once you're here, it's got to go this way. You just got to give me one more point. If we're doing these by hand, you got to give me one more point on Math Excel. You would still have to graph one more point to get the correct point, so you've got the correct curve of the graph if you're going through this thing. But again, we're going to do the shortcut. As long as this is a whole number, we're going to go up 1 over 1. The next point will be right there. Or if you want to go to the left, you're going to go up 1 over 1 to the left. Either way you go, it's going to be the same point there. It should be a graph that looks something like that.
Where did you get the up 1 over 1 from?
The A value, as long as it's a whole number, you can think about it, forget the first point, kind of like slope. That if that's 1 over 1, you can kind of cheat, and we're just going to go up 1 over 1 to get this point, or up 1 over 1 to get that point. Oh, one thing we didn't do in the last graph, which is okay. Sometimes they will ask you to draw the axis of symmetry. You just draw a dashed line right through the vertex. And that's another one of those you just have to watch. Sometimes they ask you for the axis of symmetry to draw it. Sometimes they don't. So you just have to wait and see which one they're asking you to do. All right, we haven't done one that's negative, so let's get you a negative. Okay, everybody good there before we move on? Any questions, any thoughts? Anything that makes you go, No? Okay. Used to be a talk show host that came on at night, Arsenio Hall, and that was one of his skits. His show was actually in Cleveland. He said, I was driving on the work today, driving through Cleveland, and I had something that made me go, And then he'd go on some rant, about whatever was happening. He was one of those guys that he had like a great show for like a year. Like everybody watched it. It was like, this is the show to watch. And all of a sudden it was just like that. Everybody's like, I don't like it anymore. Kind of weird because it was like huge for like a year. And then it just went away and then, never heard about it again. So, but anyway. All right. So let's go with this one. So we got -2 times x plus 1 squared minus 3. So we'll get this one, and then we got one more after this, and then we're done. All right, so let's get all this basic stuff out of the way. We've got our A value here is at -2. We actually got something other than 1 this time, which is good. The number on the inside is your H value. The number on the outside is your K value. And again, change that from +1 to -1. This one stays the same. So there's our vertex. Okay. And again, the A value by itself it gives you something, but it doesn't really do anything just from this part of it, but it tells you which way the graph is going. It's negative, so the graph has to do this, which means the vertex is at the top, which means it's going to be a maximum.
So how do you determine if the graph is like flipped upside down or
It's all an A value. If the A value is positive, it's going up. If the A value is negative, it's got to point down. Okay, so axis of symmetry. That's the x value that's here. X equals -1. All right, in this case, we know that because it's going down, the vertex is at the top. So the max value is going to be the K value of -3. Okay. Again, another one that's just domain. Again, a lot of times on this one, they don't even ask you for the domain just because every single time it's always the exact same answer. It's always -infinity to infinity. And so it's like, okay, why don't we keep doing that? Because it's the same thing every time. All right, the range. Here's where we know we got to use this one, and either we're going to go this to infinity or this to -infinity. It's pointed down. So the range is going to go from -infinity. Since this is the max number, this is the farthest number to the right or the top of the graph, then we're going to stop at -3 because that's the max number. That's our highest number, so we get to stop there. Question?
Why would it be negative for the negative? That's what I read.
Oh, okay. So which one of those is lower, -infinity or -3? Always put your smallest number first. Okay. Yeah, smallest number is always first. Biggest number is always second every single time.
So how do you know that it's going down?
If you know that the A value is negative and you just do like a quick sketch like this, the Y value, notice the arrows are pointed down. So that lets you know that, so if, like the second thing we talk about the range here, that they do it this way. And this is why I actually like this one better. And I'll probably ask for this more on the test. You can write it like this, or if you do this one, if you know it's pointed down, it's less than, and then it's just the -3. So I actually kind of like this one better. I mean, sometimes I'll ask you for this part of it, but the main thing is that if you know this is negative and it points down, then this is telling you about your range because it's chasing the y-axis. It's either going up the y-axis or it's going down. If it's going down, then it's got to be less than. Yeah, so as soon as you see the arrows this way, you know you're doing y less than.
So if A equals negative, then it will always go down.
Yep. Everybody catch that? If A is negative, it's always going down. It's always going to be less than. Okay, so we've got, make sure we got everything. We got vertex. Yep. We got axis symmetry. Yep. We got domain and range. Yep. We got the maximum. Oh, and then we just got to sketch it. Okay, so then quick sketch. We're at -1, -3, so we need a little room up here at the top left. Like that. So -1, -1, 2, 3. That would put that point right there. All right, and again, we know just from the A value being negative, we know it's got to go down. But again, we're gonna cheat just a little bit. As long as that's a whole number, which it is, to get to the next point on the graph, we can either take, we can, if we do technically what we're supposed to do, and this is where Emma can kind of just high rise for a minute. If this point's at -1, the next point to the left is at -2, the next point to the right would be 0. So technically, we're supposed to take x equals 0 and plug it back into this function and work it out. But we know a shortcut. As long as that's a whole number, the shortcut is if we do that, we're just going to go down 2 over 1. So we can go down 2 over 1 and put the next point right there. Or we can go down 2 over 1 and put that next point here, and then we've got the graph going that way. And that's a terrible, that's a bad parabola. There we go. Just make that vertex bigger. There we go. That makes it better. Okay. Yeah. When your graph gets messed up, just make the dot bigger. That usually helps. All right. And again, they may ask you to draw an axis of symmetry. If you do, you just draw a straight line right through the middle of it.
Why on this one do we go down 2 over 1, but on the other problem with 1 over 1? Because
It's always your A value. A value tells you how much you got to move to get there. So in that case, A value is -2. So if you think about it like slope, now it's not slope, but it's kind of sort of like slope that gives you the direction of the graph. So if the A value is -2, that means we're going down 2 over 1. The other ones were always just 1, so it was just up 1 over 1. So, okay, so now we're getting kind of close. Everybody okay there? Any thoughts, questions? All right, so the last one we're gonna do, we're gonna skip all the fluff and stuff on this one because I want to give you one with a fraction. All right, so let's go with this one. All right, we're gonna skip a lot of the stuff on this one. We're just gonna get we're gonna graph it basically is what we're gonna do. We're not gonna worry about domain and range, all this stuff on this one because we're running short on time. We'll make sure we get this in. All right, if you graph it, you have to have the vertex. So that part of it we still need it. So when we get the vertex here, it's at -2, +1. Okay, it doesn't matter what you do anytime what it says you have to get the vertex every single time. All right, the a value is 1/2. All right, now here's where the shortcut does not work. If the shortcut being a fraction, or if the a value is a fraction, you cannot use the shortcut. It will give you the wrong answer because it only works for whole numbers.
What about the even number and the vertex fraction? Can we still use the shortcut?
It's just the a value. If these are fractions, it's fine. But if this is a fraction,
So only
if the a value is a fraction, there is no shortcut.
Okay.
You have to do it the long way, which is unfortunate, but you kind of have to. If there is a shortcut, I haven't found it yet. Or because it depends on what the fraction is. If it's this, then you do this. But if it's that, then you do that. So it's like so it's easier just to kind of go through this one. So go ahead and kind of sketch this thing. All right, we're at -2, 1, which will put us here. All right, we do know it's positive. So the one thing we do know is the graph has to do this. We just don't know how much. And again, we cannot go up 1 over 2 because it doesn't work out that way. If this was just x plus 2 like this, it would be. But because of the squared part, because when you start squaring fractions, it doesn't always equal out that it's going to be 1 over 2. It's not even going to be 1 over 4, which is not going to be wrong. This is one you just have to plug in the next number beside it. So if the x value is at -2, we either have to plug in x equals -1, or if you want to go this way, you can plug in -3. That's your choice. And I'll be honest with you, if you plug in going to the right side, your number should always be positive. So let's go to the right side. Let's go plug in -1. So that's 1/2 times -1 plus 2 squared plus 1. All right, so that's -1 plus 2 squared. That's still going to be 1. And if you square 1, it's still just 1. So if we do 1/2 of 1, that's just 1/2 plus 1. So that's 1.5. And then somebody may be saying, well, how are we going to do that? Because 1.5, depending on how it is, sometimes you may not be able to put 1.5, right? So if that doesn't work, then we're going to have to pick another point. Instead of picking the next point right beside it, we might have to go to the next point over. So now we're going to plug in x equals 0. Because, I mean, we could try this one. -1, 1.5 is about here. But if you don't have it already split in half grids, it's not going to work because it's a fraction. It's just not going to be there. So we're really going to have to pick another number here. So x equals 0. So that means it's going to be y equals 1/2 times 0 plus 2 squared plus 1. Okay, so that's 1/2 of 2 squared. 2 squared is 4, so that's 1/2 of 4, which is 2. That's 2 plus 1, so that is 3. Okay, so in that case, we plug in 0, we get 3, so that's at 0, 1, 2, that's at 3 up here. Yeah, so in that case, that's what we're saying. If it's a fraction, you can't use that kind of slope shortcut because everything is squared. Everything gets a little funky and it gets, because it's stretching and it's going fast. So unfortunately, this is one of those cases where you just have to plug in numbers till you can find one that actually fits on the graph here. So, so that one we're going up 2 and over 2 to get to this next whole number that we've got here. So if we went up 2 and then back 2, that would put the next point back here. And that's terrible because that's going through all my points here. All right, so the bad news is if it's a fraction, there's not any quick, easy way to get there. You just have to plug in some numbers before you get there. Did I not take that over? I didn't take that over far enough, did I? I should have been -4.
Because we got 3, but you moved it up 2.
Correct, because this point's at 0, 3, correct? So if we go 1, 2, 3, there's that point at 0, 3. Yeah. And again, if this shortcut the equals, let me just scratch this out of the way. If that shortcut of a equals 1/2 works, we should have gone up 1 and over 2 and put this point. But now that we look at it with the fraction, it's not that point, it's actually up above it there. So fractions, for the a value, there is no shortcut. You just have to plug in a number. And probably, honestly, in this case, probably what you want to do is that if this thing is 2, whatever that denominator is, that's how many spaces you need to move over. Because if you move over 1, you're probably going to get a fraction every time. If this thing is 2, then you want to move 2 spaces over. If this had been 3, you probably want to move 3 spaces over. So whatever that bottom number is, that's usually, it kind of gives you a hint as to which way you want to move to get to the next point that's there. Okay, so that's the bad part. Fractions with a value, there is no shortcut. But if it's a whole number, you know, like this, it's good to go. We got a shortcut to get from this point to the next point that's here. So we can do something like that. So, you know, fractions, not so much. They're going to make you work a little bit just because they're fractions. That's what they do.
I'm confused. Why do we go up 2 over 1 and then up 1 again?
Oh, that once if this is a fraction, other than telling us the shape of this one, it doesn't tell us anything else. There's no up and overs if it's fractions. So what we have to do then is we just have to take values and plug in numbers until we get points that are on the graph that we're going to plug in. So like we plugged in 0, we got 0.03. So that point was here. And if you drew your axis of symmetry here, this is 2 spaces this way. So that means you also could go 2 spaces that way and get the same point. Because everything should be spread out equal from the axis of symmetry. So basically, if it's a fraction, you just got to plug in numbers until you get ordered pairs to graph on the thing. All right, so 1 of 2 options here. Messed up.